Alright, for our topic today, we're going to be talking about multiplication properties of exponents. So, you should have explored in the lab and found out that a to the m times a to the n is really a to the m plus n. So the rule is that we're going to add those exponents together. I will explain to you logically why that is as we go through some examples, in case you have not completed that lab. But as we look at this problem, what we really have here, and here's the logic behind it, we have 5 times 5 times 5, and then here we have 5 times 5 times 5 times 5 times 5 times 5, 6 times. So if I go ahead and place this time sign here between them, I now have it's really 5 to the 9th power. Now if we just learn that rule and we're able to keep that rule in our head or think about it logically, we can just directly go to our answer of 5 to the 9th. Because of how large 5 to the 9th really is, I am not going to multiply out 5 times 5 9 times. So I'm just going to leave my answer as 5 to the 9th. Most of the time I will go ahead and say what that answer is. So in the next problem here, these are the ones, I'm going to underline them in different colors that have the same base. So the rules, and I am going to start talking about the rules, is we keep the base and we add our exponents together. So we'll be adding 4 plus 2, which is 6 times. Okay, we're going to keep our base. And we're going to add our exponents. Negative 3 plus 6 is 3. Again, because of how large the numbers are, I'm going to just go ahead and leave my answer like this for right now. Please never, ever, ever tell me that this is 21 to the 9th power. You cannot do that because they do not have the same base. The only thing we could do if we wanted the actual number is to actually put in our calculators, either using the exponent part of our calculators or typing them in by hand. 6 3s multiplied together and then 3 7s multiplied together, and we'd get a rather large number. On this next problem, let's go ahead and use the rules again. Keep the base, add the exponents. Negative 3 plus 3 is 0. We know that anything to the 0 power is 1. The next problem, I have Q's and I have R's. My Q's, I keep my base. I add my exponents. 3 plus 6 is 9. And then my R's, I'd have R. I'd have 2 plus what's here? Well, there's a 1 there, so 2 plus 1 is 3. So my answer would be Q to the 9th, R to the 3rd. The next rule we want to talk about is the A to the M to the Nth. So we have a power to a power. We are going to keep the base, and we're going to multiply the exponents together. I want to explain to you at least one problem of that logically. So what this really says is I have 5 squared 4 times. So if I write that out, 5 squared times 5 squared times 5 squared times 5 squared, this is what I have. But now if I even take that further, I have 5 times 5, because that's what 5 squared is, times 5 because that's what 5 squared is, times 5 because that's what 5 squared is, and then 5 times 5. So I end up with 1, 2, 3, 4, 5, 6, 7, 8 5s. Using that rule of power to a power and just multiplying those together, I could just multiply 2 times 4 and get my answer of 8. So we're going to use that rule from here on out. We're going to say this is 4 to the 3 times 0. 3 times 0 is 0, and I know 4 to the 0 power then is 1. This next one we really need to be careful on because we've got 2 rules being used. We do need to take care of the power part first, the exponent to an exponent part first because of rules of order of operations. So I really have x to the 4th times, I need to take care of this part first, so 3 times negative 5 is x to the negative 15. Now we have the same base. We're going to add our exponents together. And so I get x to the negative 11. This one, we're not going to leave our answer in that form because it's not happy, so I highlighted it, and I need to make it happy, and I'm going to move it to the bottom of the fraction. So my answer ends up being 1 over x to the 11th. Sometimes we've got more than one thing inside the parentheses, and so we have to take each of those parts to the exponent, or raise each of those parts to the exponent. So we need to make sure that you know that you're going to raise everything that's inside the parentheses is raised to the power if everything is multiplied. So as we look at all these are all being multiplied together, so we are going to raise each of these to the power. So what that means is we're going to use our rule each time. We're going to multiply these numbers together. So I've got x to the 6th, 3 times 2 is 6, and y to the 8th, 4 times 2 is 8. This next part, the negative is being raised to the second power. So I'm really saying negative 3 to the second power. I'm also saying 8, or x, 8 times 2 is 16, x to the 16th power. Negative 3 times negative 3 is 9. And then I have x to the 16th power. On this example here, I have x to the 6 times 2 is 12, and then I have y to the negative 3 times 2, which is negative 6. This is the one that is not happy, so this is the one that needs spots. The x to the 12th is going to stay where it is, and the y of the 6 is going to move to the bottom of the fraction, so it becomes happy. And so my answer is x to the 12th over y to the 6th. Continuing on, we're going to simplify each expression, which means that we will not have any negative exponents. The same base will not appear twice. We won't have any power to powers. We'll have no parentheses, and we'll reduce all our coefficients. So we're going to look at some more complicated problems, and we're going to have to make sure that we're going through each of those things. So we're going to get rid of all the parentheses first. And so we're going to raise these all to this power. So I've got 3 to the 3rd power. And I've got x to the 5 times 3, so that'll be x to the 15th. Times, I've got 2 to the 3rd. And I have x to the 2 times 3, which is 6. That's power to a power rule. Now if you want, what we can do is let's get rid of these numbers. And I have 3 times 3 times 3, which is 27, x to the 15th, times 2 times 2 times 2, which is 8, x to the 6th. To finish this problem, we'd multiply the 27 times 8, just like we always have. We'd get 56, and so we get 216. X, keep your base, and now we need to add our exponents together, because when we don't have power to power, we are actually adding those together, because this would be like having 15 x's written in a row and 6 x's written in a row, and so now we have 21 x's all together. The next problem, again, let's get rid of the power to, or the parentheses part first, so it says power to the power, so we've got 4 to the 3rd power, because this is 1 times 3. I've got x to the 5 times 3, which is 15, times, I've got just negative 2. This one's not being raised to any power except 1, so I've got negative 2 to the 1st power and x to the 3rd power, x to the 3 times 1 power. Now if I look at this, don't multiply 4 to the 3rd times negative 2. You need to first do 4 to the 3rd. 4 times 4 times 4 is 64. X to the 15th times negative 2, x to the 3rd. 64 times negative 2 is negative 128. X to the, I have 15 x's written in a row, and here I have 3 more x's written in a row, so I have 18 total x's. Next problem, we have some parentheses here. This is the part that's in parentheses, so I've got b squared times b to the 3 times negative 2 is negative 6. Now I have the same base, so I keep my base and I add those together. So 2 and negative 6, 2 plus negative 6 is negative 4. Highlighting this because it's not happy, there are no negative exponents in our answers, so we'll move this to the bottom of the fraction and we'll put a 1 on top. Alright, finishing up this lesson, we have a few more problems. We're going to continue on the path of the word, which we're raising each of these to the power first and getting rid of the parentheses. So I've got 6 to the 3rd, n to the 3rd, n to the 3rd, times 5 to the 2nd, n to the negative 3 times 2 is negative 6. I have 6 times 6 times 6, which is 216, m to the third, n to the third, times, I have 5 times 5, which is 25, m to the negative 6. I need to multiply 216 times 25. I'll just do that quickly on a calculator. So I've got 216 times 25 gives me 48,600. 48,600. M to the 3 plus negative 6 is negative 3. N to the third. Now we're not finished because this m is unhappy. It does not want to be on the top of the fraction. So we move it to the bottom of the fraction. And we keep the other things where they were. Our next problem, this one is raised to the first power, so I really just have 4x y to the third times, then I have x to the negative 9th. This base has a power of 1, so I'm really saying I have 4, I have 1 plus negative 9, that's x to the negative 8th, y to the third. No negative exponents allowed in my answers at the end. This one's not happy, so it moves to the bottom of the fraction. Everything else stays on the top. In my last two problems here, what I really have is I have parentheses, which means I'm multiplying, but everything in between is being multiplied as well. So we can multiply these in any order we so desire. Because of the rules of multiplication and that being we can do it in any order we want, it would be much easier for me to multiply 1.5 times 3, which gives me 4.5, and then to use my rules of exponents, which says keep your base and add your exponents together. Negative 2 plus 4 is 2. Now this happens to be in scientific notation, so I'm going to finish because this number is between 1 and 9. The last problem here, we're going to do the same thing. These parentheses really mean nothing because everything's being multiplied together. So I'm going to multiply by 9 times my 7, which gives me 63. And then I'm going to multiply or keep my base and add my exponents together. So I get 10 to the negative 15. Now, most of us find it easier to change this into standard form first, rather than trying to put it strictly into scientific notation. Now, if you're able to do that, then that's fine. I'm going to change this into standard form first, which means I move my number over, my decimal over 15 spots. So that would actually create 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros. So this 63 times 10 to the negative 15 is this really, really small number. In order to change this into scientific notation, I need to place my decimal between the 6 and the 3, so I'd have my first number between 1 and 10. So now I'll say 6.3 times 10 to the, that would require me to move it only 14 spots, and I do want my number to be really, really small, so I want it to be a negative exponent. And now I have it in scientific notation.